USC Viterbi School of Engineering Faculty Roundtable session. My name is Paul Ledesma. I'm the Director of Undergraduate Admission at the USC Viterbi School of Engineering. Today's faculty roundtable discussion is with the faculty from the Daniel J. Epstein Department of Industrial and Systems Engineering. We have three great faculty members here to talk to you a little bit more about themselves, the discipline and the department. And so without further ado, we're going to get into introductions with each of our faculty members. Actually, wait, I'm going to hold that. We're not going to do introductions yet. I'm going to lay out the ground rules for you. Let's do that. For all of you that are attending, thank you for doing that. Here are the ground rules for today's session. Number one, we're going to ask you to hold all of your questions. So while we will have an opportunity to get questions from you live, please hold your questions from now. No questions for the time being. We'll get to that in a minute. I'll let you know when I announce that. We're going to have the faculty do a discussion. We're going to talk about the curriculum, the department, the courses that you're going to take. And we're going to learn a little bit more about that. And that may help guide your future questions. So please hold those for the time being. And also the other thing too is that if I do have to do this, if you start asking questions before I let you go, then I will have to, if you do start asking questions, I will have to deduct points from your application. So we don't want that to happen, even though you haven't applied yet. But without further ado, let's let our faculty introduce themselves, because this is the order that you're in my screen. We'll start with Dr. Palmer, then Dr. Moore, and then Dr. Kashi.
Hello, my name's Kurt Palmer. I'm a member of the teaching faculty of the department, which means my primary responsibility is to teach classes. I also have an administrative role. I'm the associate chair of the department, which in that role means that I help our department chair and others try to manage the undergraduate program, make sure that we're offering enough classes, that everybody gets to take the courses they need in plenty of time to pick up their degrees in 4 years. As far as the kind of courses that I teach courses in statistics and simulation and quality management.
Have you concluded, Kurt?
Yeah, go ahead, Jim.
All right, I didn't want to cut you off. Hi, I'm Jim Moore. I've been at USC 32 years. I've been an academic for 34 years. I've had multiple appointments, including public policy, civil engineering, and industrial and systems engineering, which is currently my principal appointment. I study primarily transportation systems with a focus on urban transportation. I teach courses, well, I call it statistics for non-believers over in the Price School of Public Policy. There are no volunteers in that class. And then optimization in the graduate program in the Epstein department. Pardon me, I also teach, I co-teach the senior capstone design course, which is a year-long sequence. It's team-based, it's project-based, the projects are real. There are external clients. No money is changing hands, but we work with clients who are anxious to have a problem addressed by our students. And our students usually spend the first semester figuring out what the problem is and the second semester trying to execute a solution, and then they graduate. And so everybody's usually in a pretty good mood. And I'll stop it right there.
That's a good one. We're going to definitely want to come back to that in more detail in a little bit. So thank you for that. Dr. Kashi.
Hi, my name is Yalda Kashi, and I'm a faculty at the ISC department. So I did my undergraduate in industrial engineering. I worked for 4 years when I was doing my undergrad as a quality management consultant, about a year and a half after graduation as a project manager. Then I started my master's degree in ISC and then PhD again in ISC. Fun fact, I did graduate from the very same department. I did my PhD at the Industrial Systems Engineering department. And then I did my postdoc in Technology, Innovation, and Entrepreneurship program. I loved our department so much that I came back for a full-time position, and I've been here ever since. My main area of research is human factors and ergonomics, and the courses that I teach is project management, quality management, which makes sense given the background, and also human factors. My passion about human factors is I look at the role of the human in the complex technological systems, and that's it.
That's fantastic. I definitely want to come back to human factors as well, because I think it's a fascinating area that a lot of people don't know about. But before we get into some of that detail, I think one of the first questions we should start with, obviously we have an audience of prospective students and their parents that are learning more about the discipline. Let's talk about industrial and systems engineering. So this is seemingly a simple question, but it probably has a complex answer. What the heck is industrial and systems engineering?
Well, Paul, that's a question that our profession has been struggling with since its inception, which, depending on who you talk to, dates back to, essentially World War II in sense. Industrial engineers are, first of all, engineers. We're like everybody else in terms of we care about how things happen. We care about how things are made. We care about how things are done. The thing that makes us a little bit different is that we include people in the systems that we're interested in designing and managing. So we take a look at a place like Staples Center, and we're interested in, well, what does it take to switch that over from a basketball arena to a hockey arena? We also look at places like Disneyland, and in better times, we'd worry about how do you get people in the gates and to the different rides, and then maybe to the restaurants and the gift shops too. And of course, our foundations are in manufacturing, so we're always interested in, how do you make things better, more usable for customers, less difficult to produce well for the employees working for the companies. That's sort of a thumbnail.
That's a good thumbnail. Any other thoughts?
Just following what Dr. Palmer just said, we are not only looking at humans in the system and the technical part of the system, which as engineers, we do look at and study the technical part of it, how the system is made, the technology. We also look at the interaction, basically how the human in the system is working with this technology, how the overarching organization that's managing these two is doing the work that they're supposed to do. So for example, when we're looking at transportation, aviation or railroad or any other type of industry you want to look at, not only we are looking at how you are making that train that is doing the transportation, how we are doing the scheduling, how we are doing the system in general. We're also looking at, okay, what is the training procedure for the engineer who's supposed to be running that train? What is the training procedure or the communication procedure for the engineer and the dispatch control systems? And we are also looking at that interaction to create a safe, optimized systems that is doing the job that they're supposed to do.
Given that there's no one here from the Marshall School of Business, I will go ahead and say that industrial engineering degree is what a business degree would be if business took math seriously, which they don't. And I'm overstating that a little bit. If I were to design such a degree, it would be a little bit different than what most industrial engineering degrees are, but not much different. We suffer from a label, I think, that we inherited. So we rose with Gilbreth and Taylor really in the early part of the 20th century. And industrial captured a lot of the focus that the field actually was attempting to support. And that has changed. We are much more interested in general in processes and optimizing processes and managing circumstances in which there's a contention for resources to try to get something important done. We just take that approach and we combine it with enough technical depth that we can focus on engineering processes in a way that most others cannot. And I'll leave it at that for the moment.
That was great.
I think I'd do one more slight follow-up, if I may. One of the things that we worry about with regard to resources that also distinguishes us from other types of engineers is we realize that you not only need equipment to get things done, you need other resources like money. and so when you go to a manager and you ask for resources, you have to talk to the manager in the language the manager understands. How much is this going to cost, and what's the benefit financially for us doing that? So yeah, we spend a lot of time worrying about the economic performance of the organization as well as the what has to get done performance of the organization. And that puts us sort of shoulder to shoulder with management, much more so than a lot of other engineers are.
One of the summary points that sometimes I describe, but I think that I love how you all laid it out, is that industrial systems engineers are efficiency experts. And I also like to use the term they engineer better businesses. This idea of if you have this continuum of science to engineering to anything else, you got a physicist will tell you theoretically how something could work, an electrical engineer will tell you this is how it could work because we can do all this, and an industrial system engineer can tell you how it's really going to work in the real world. We're going to make this all kind of go directly to market. We're going to make sure this is actually going to run appropriately. This is how people are going to use it. It's how it's going to be manufactured. Does that sound fair as kind of a fun summary of that?
Sure. Yeah. We're the ones who make sure it actually gets on the shelf.
Yeah. And honestly, you're kind of the silent stars, right? You're in every industry. And a lot of people don't know that exists, this idea of someone making sure it's really going to work. So that's something that a lot of people don't know. Let's talk about the curriculum a little bit. Can you walk us through the undergraduate curriculum? What is someone going to do as they work their way through this 4-year program of industrial and systems engineering? And what are some of the classes they're going to take? And I'd love to end on that capstone course, Dr. Moore, that you talked about.
Okay, so let me walk you through from the beginning, and then we'll have the big finish with Dr. Moore. Okay, so like all other engineering degrees, we start off with the fact, well, like every degree at USC, let's start off with general education, right? We have a series of courses that you need to take to appreciate the world in which you're going to be doing your engineering. So yes, there's quantitative thinking in there, but there's also sociological kinds of issues, like how does an engineer deal with customers in other countries? Because not everybody actually thinks the way that we think here in the US. They have different value systems, different decisions about what's important, in terms of the relationship of the individual to the society. And so you have to have an appreciation of the fact that people do vary across the world, and yet we still want to do business with them. We still want to sell them products. We still want to work with them on teams. And so, you have to have an appreciation. And of course, these days, we're very much aware of our ethical and moral responsibilities as people who are putting products out into the world to make sure those products aren't going to be hurting people or damaging the environment or other undesirable things like that. So you have to have an appreciation of how society views the work that you're doing, and that's what the general education component of your coursework is for. Then we get into the basic foundations of engineering, which engineering is applied science, really. So you have to have a good idea of basic sciences and mathematics. And so you're going to take some courses in calculus, some linear algebra, some physics, some chemistry, some biology, just so you can understand what are all of these physical phenomena that we're going to be exploiting as engineers to try and make products and services. Then we get into the meat of the degree, right? So you've got what we call the core of the degree, which is a set of courses that all of our undergraduates study. And this is intended to give you a broad overview of the many different sub-disciplines that there are within industrial engineering. And oh my gosh, are there a lot. So you get some statistics, you get some optimization, you get some human factors, some manufacturing scheduling and production planning kind of things, economic evaluation of projects, designing information systems, basic organizational structures and how people interact with technology. And I'm just, very quickly listing a whole raft of topics there. We could go into any one of those in extensive detail, but I won't do that right this moment. And then after we've got the core in place, after we've given you that good foundation, we have in our degree structure what we call focus groups. And these are elective groupings of courses that start to specialize you in different areas of professional practice. So our most popular focus right now is called operations. And that has to do with how do businesses get things done, whether you're a business that's making automobiles or you're a business that's making smiles like Disneyland, right? How do you manage to do the things that you need to do on a regular basis to meet the needs and desires of your customers, right? And then a second area of focus that we currently call information systems. And that, at least as it's currently designed, is looking for how do you set yourself up to be an intermediary between the management of an organization that needs to be able to manage the myriad sources of information like customer information, suppliers, employees. How do you get your hands around all of that and make use of it to do the things you need to do? So, a very quick example of that, I'm sure you've all shopped with Amazon at some point in your life. And when you go to Amazon and you put in a description of a product, you get that product. It's a great search function that brings up from all of the products they have, the one you're looking for, but then it also has suggestions of alternative products that do similar things. And it's an information systems designer who's created that by searching all of the different searches and purchases that Amazon customers have made and creating linkages between them, and noticing that people who look for little carts to roll around in their home so they don't have to carry the dinner dishes from one room to another. If they, like I do, I tend to eat in the living room. People who look for those things also look for other things like sprays to clean up stains on the carpet. Okay, so and the reason I've been couching my discussion in saying that emphasis has had that, or that focus area has had that emphasis historically, is that we're now in the process of thinking about redesigning our undergraduate degree. And some of the things we're thinking about adding in with that focus are issues such as what we call analytics, which has to do, how do you take huge data sets about lots and lots of information and pull out of that important bits of knowledge that, like looking for those linkages between product searches and purchases. So a little bit more of that in the degree as we move to the future.
Would you say that students that have interest in data science might find that interesting?
Absolutely. I think there are a lot of aspects of data science that we're going to pull into the degree as we begin to freshen it up or modernize it for the next generation.
Right. Other thoughts on the curriculum? Or actually, let's go to Dr. Moore's that capstone class. Hands-on coursework, hands-on elements in coursework is important throughout the education, but this is a great kind of end-all, be-all, this consulting course. Can you tell us a little bit more about it?
Well, Kurt's accurately described our efforts to change the curriculum. We are modernizing, but we aren't antiquated at this point. We've been trying to keep up throughout. It's just a process that never really ends. So the all of our, with the exception of applied mechanics, and that's not our program, all of our undergraduate programs are accredited. So if you graduate from one of our programs, you can sit for the engineer and training exam, and after 2 years of service under a licensed professional engineer, if that's what you'd like to do, you can earn a profession. You can qualify as a professional engineer and be certified by the state. Almost none of our graduates actually do that because it's really important for civil engineers. It tends to be much less important for industrial engineers. Because they don't need that certification to exercise many of the opportunities before them. It does, because we're accredited, force us to take some important quality control steps in our curriculum. And one of them is the role of these capstone courses. And that's one of the reasons that all of the departments have one version or another of a capstone course. It's because it's required for accreditation purposes. And we kind of like them. Now, I'm a little biased, but I think our capstone course is the best because most of them are a semester long. Ours really is a year long. It exists largely in Its current form, I think due to the influence of a former department chair, Stan Settles, who had been a vice president at Honeywell and who was a member of the National Academy of Engineering. This was a format that he was very much interested in promulgating, and I'm glad that he did, and I'm glad we listened to him because I think it's really going very well. Almost all of our undergraduate classes are instructed by full-time personnel. This capstone class, is a bit of an exception, in part because it's so industry oriented. It helps to have people directly involved in the class who have been making their way in the world in industry. So I'm a full-time faculty member, and that's really all that I do because it's all I really know how to do. But we have a couple of additional professionals, Ted Mayashiba, Dr. Paul Liu. Paul was with, I'm having a senior moment, aircraft firm. Gulfstream, thank you. I appreciate it. So he was a vice president with Gulfstream in charge of international operations. He's a very sophisticated person. Ted Mayashiba makes his living as a consultant. He goes out and he reaches out to clients who have got various problems they need solved, and he brings industrial engineering techniques to bear to solve them and help them improve their processes and improve their bottom line. And he's able to turn a good living by doing that. And so he comes and he teaches our students how to take the tools they have acquired in their various courses and make decisions about how to use them in this real world context. And it is a big, I don't want to say it's a burden to coordinate. It's a challenge to coordinate at times, because if you've got a large class, that's a lot of teams and a lot of clients, and there are a lot of meetings. We've got a very prescribed process to go through to help students address in a formal way the kinds of problems that they're going to face on the job, and ultimately to come up with a successful remedy for that problem, maybe something so strong it even qualifies as a solution to the problem. And every once in a while, we don't quite get the team to where they want to be, where we want them to be. That doesn't mean that they're going to receive a bad grade in the class. It just means that part of what we're trying to do is actually generate a solution. So that remains an important goal for us. And I'm happy I got an opportunity to teach the class. So continue to teach it for as long as the department will have me in that role. And I hope you all apply to the Viterbi School, and I hope you all major in industrial engineering, and that I eventually get to see you in that capstone class.
It's an incredible course, and I think it's a student favorite as they get to work directly with industry and start figuring out what they want to do as they move on. Let's transition a little bit and talk a little bit about research in industrial and systems engineering. And Dr. Kashi, you had mentioned earlier the idea of human factors. I'm not certain if you want to start with that, but I did want to make sure and come back to human factors at some point.
Yeah, definitely. So research, USC is one of the best university in the country in terms of research, especially in our graduate programs. But there's been this new initiative with the Viterbi School of Engineering to get our undergraduates more involved into research. So we have this program called CURVE. Don't remember what exactly CURVE stands for, but we are actually giving the opportunity to our undergraduates to apply to different research positions that faculties have available, and they do get compensated if they are part of the program. They're chosen to be the part of the program for the time that they're spending on the research, aside from faculties who do actually have undergraduate students working in their labs and working with them directly. So one of the things that we do during this program, and for example, right now I am working with a couple of students, is working in different areas. My area is human factors and ergonomics. And I can give you an example of the work that we're doing right now is we're actually looking at how virtual health or digital health, because of the COVID pandemic and everything, suddenly all the appointments were shifted to this digital environment. And we're looking at how this shift to this virtual and digital environment is actually affecting the quality of care that patients receive. So for example, one of the things that we're looking at is how this digital interaction between the human and the technology, again, looking at the interaction between the human and the technological part of the system, is affecting the quality of the care they receive by simply like miscommunication, because now you're not just sitting in front of the physician and there might be cues left here and there. The other part of the human factor, so that is more like macroergonomic. The other part of the human factor is the design of the work systems that we are using. The simplest version of the work system is the setting that we have right now, sitting behind the desk and working, and it gets all the way to designing the aircraft or designing the nuclear power plant control room, and how we are looking at to create the safest, most efficient way for people to interact with the system. We do have other research areas in our department that I think Dr. Palmer and Dr. Moore can give you a better perspective on that.
Thank you.
Go ahead, Jim. This is part of your normal daily activity.
All right. Well, so I've described my own research as a focus on transportation systems. There is a strong economic component to that, and there is an optimization component to that. And a lot of the research that takes place within the department, I would say, includes a focus on optimization, not to the exclusion of other areas, but it's an important tool. It's a tool that has been expanding in recent years. Analytics has got an optimization element to it, but I'd say analytics is an overt combination of data science and optimization. And I may be oversimplifying there. There are people involved in those fields who might disagree with that assessment, but that is in general mine. We've got folks that are really very computationally intensive. Carl Kesselman is the father of grid computing, really. He more or less invented it, and I say that, fairly secure in the statement, right? We've got a colleague who didn't quite invent additive manufacturing, but is one of a small group of people who did, right? And that's become very important these days, and it will continue to be more important. And I think a lot of the research that I see emerging right now is beginning to converge on what is loosely called the Internet of Things and the fourth industrial revolution, where we're going to find ourselves blending applied mathematics, data science, and manufacturing in ways that they haven't been combined before to establish real-time control of some fairly complex and highly productive systems. And so I would say that that's where I see a lot of the research taking place in the department ultimately adding up to. And that touches a lot of different skill sets. So everybody gets a chance to play. I mean, everybody can contribute something in that general gestalt of activities. And I don't think I've left anybody out. Human factors. Okay. I'll leave it at that. I don't want to. I can talk. I love to hear myself talk, so I'll just keep talking left to my own devices.
That was good coverage. One of the final things we're talking about is where students go after studying industrial and systems engineering. They're interning at a number of different companies while they're there, and they go on to get full-time positions with different companies. Where can students kind of see their predecessors heading off to?
Okay, so it's essentially everywhere and anywhere you can think of within the economy, to say it simply. Yep. To be a little bit more detailed, each spring semester I do a survey of our graduating seniors. And just to give you an idea of some of the places where they've told me that they're getting their first job offers and doing their first activities after college, a number of them go to work for the big management consulting companies. I'm talking about Accenture, Price Waterhouse, Ernst & Young. Right? And the thing that draws them towards that is the idea that they're going to work in a variety of different application areas, that they're not going to be doing the same thing day after day after day. And they find that extremely appealing. Right? There's another group of students that end up going to work in organizations that provide consumer products. I'm thinking about Microsoft at the top of that list. And you might think of Microsoft and say, consumer products? I thought they were a software company. But they actually make things like Xboxes, and Surface laptops, and our graduates are helping them manage the supply chains that are providing those products to the public. Right? Other manufacturing organizations that our graduates have gone to work for, aerospace organizations like Northrop Grumman and Boeing, food production like Pepsi and General Mills, retailers like Target have gotten some of our students. The list of service organizations is longer than my arm, quite literally. But companies like Amazon, United Airlines, let's see, Adobe Systems, there's a couple of real estate organizations in here, a few financial organizations like Goldman Sachs, entertainment organizations like NBC Universal, and it just goes on and on. Utilities, Southern California Edison, for one. And then, of course, there are those who decide to continue their education, so they'll go on to master's degrees or doctoral degrees at other universities. And of course, the most popular place for a student to do graduate education, having graduated from our department, is USC. They stay here and do a master's degree with us.
Absolutely. And lots of different opportunities in master's degree education, engineering management, financial engineering. It just keeps going on and much more detailed as well than just the undergraduate programs. And so with that, I'm going to open up the Q&A for everyone else. If you have questions, go ahead and start shooting them off. And while we wait for students to come in, I'm going to ask one fun question to all of our faculty. And this is, if you were not a professor, what would your younger self be hoping that you would have become right now? What would you be doing professionally if you weren't a professor?
I've had so many different career segments along the way. I could have ended up in any one of them long term. I started off as a chemical engineer and went to work for a company called Eastman Kodak. Worked as a manufacturing engineer for them for 6 years. Along the way, I was introduced to statistics, and when I left Kodak, I started my own statistical consulting company in focusing on quality management. So I could have ended up being a 40-year technical ladder engineer at a company like Kodak. I could have ended up being a quality management guru like Joe Duran or Edwards Deming. Or I could have ended up being a professor at a university. And all three of those are wonderful ways to spend a career. It just depends on what floats your boat.
Other.
I can go next. So I think I gave you a very quick background of what I was doing before I started my master's degree program. But honestly, when I started my PhD, I was supposed to work on the same area of quality management and quality improvements. And then I met my advisor and mentor, and my whole research future shifted towards human factors, something that I really appreciated now. But still, I wasn't really thinking about teaching until I started teaching at USC, and then later at Cal State and Pepperdine, and then come back to USC. And I think I mentioned it the last time that we had this roundtable that Professor Moore here, he was the first one who hired me for a teaching position at USC. So if you ever apply to USC and get admitted and sit in one of my classes and you have any objection, you can go to Dr. Moore. He was the one who started it all. So you can blame it on him. But if I wasn't here and I wasn't doing this, my younger self really wanted to be working at United Nations UNDP program, United Nations Development Program. So I think that would have been something else that I would have been very interested in.
I've reflected on this, and this is the best job that I can have imagined. So it's really hard to get my head around what I might have been doing instead. I was a paramedic before I went to college to figure out if I wanted to be a doctor, and I absolutely did not want to be a physician, and I do not want to be a paramedic. In addition, I would say, okay, I did take a job that I ultimately backed out of at Oak Ridge National Laboratories. And if I had taken that job, I would be focusing on the location of the nuclear waste repository that we badly need. And if I had taken the job, I would still be at Oak Ridge, still focusing on that very question, right? And wondering what I had done with my life, since we haven't actually managed to make any progress in the question. I suppose, if knowing what I know about the world right now, I would aim for finance. If I was not doing this, I would aim for a quantitative finance position. And I might make a little bit more money, but I can't guarantee that I'd be any happier, because I frankly can't imagine being any happier than I've been here for the past 30 years.
Usually I would say, really, your younger self would want to be going to finance, but knowing you, Jim, I'm sure, yes, that is your younger self saying, yeah, probably going to finance.
I'll take the compliment that I detect in there somewhere.
It's a compliment. Okay, let's get to some of these questions. There's some great questions here. We're going to get to as many as we can. As a reminder, I put it in the chat, but we're not going to answer any admission or application questions today because we have these faculty here. Let's talk to them specifically. If you do want to, I put a link in the chat so you can join us in one of our admission sessions. We will get to all of those questions at a different time. Let's start with Jake's question. Jake, great question from it. Jake Olson. Do Viterbi students get to interact with their professors directly in and out of class? I'm assuming this means he likes you and wants to know whether he can interact with you, or he might be scared of you and doesn't want to. So let's be cautious about how we answer this question.
Well, it's the case.
Sorry.
Go ahead, Gal.
Sorry, go ahead. I just wanted to say, as a former ISC student, I never had any problem approaching any of the faculty and getting an appointment to meet and talk with them. And as a faculty, I know I always welcome and enjoy having conversation with the students. The only thing that you need to do is just shoot an email and ask for an appointment, or just show up to an office hours and they're there for you. That was my experience.
Great to hear. I spent 25 years in the resident faculty program, living in an undergraduate residence hall. And I felt pretty much in touch with those students. Some of them were ISC students. I direct a program in other departments. There's a lot of work. There's a lot of contact outside the classroom that occurs. Call it morale building, basically, cohort building, trying to make sure students know each other and they know us and they know the faculty who are instructing them. So I think by and large, most of the personnel in this operation see a lot of value in that.
Yeah, I think one of the advantages of USC, especially as I compare it to the state schools where I did some of my other degrees, is that our class sizes tend to be smaller, especially at the undergraduate level. We, in our department, work very hard to keep our class sizes fewer than 40, and most classes are on the order of about 30 students. So with that size of a class, it's certainly quite feasible, and I make it a point of pride to be able to know all of my students by first name before the end of the semester. So I can, be referring to them, asking questions, during the class sessions. And when they come to visit me in office hours, that I recognize them and, address them by name. The most common type of interaction I've had with students, other than course related, is through our professional societies. We have a chapter of the Institute of Industrial and Systems Engineers affiliated with our department, but we've also got 3 or 4 other professional societies that are also linked to the department. And each of those societies has a faculty advisor. I've been advisor to a couple of them over the years, and getting to know the officers of the society, the members of the society, working with them regularly to organize campus speaker events and other activities, I think is another great way to take advantage of the opportunity to have connection with a faculty member outside of the classroom.
I think we have some faculty here that also are incredibly modest, and I will tell you that they know their students. They interact with their students. Our students know the faculty. They engage with them on a daily basis. This is a place where you're not going to get lost in that shuffle. But I will warn you That does come back to bite you in the butt sometimes. This is not a place where you just get to miss class because it's a large lecture hall and you disappear. I've often seen faculty members in that cafe run into somebody in the awkward situation where a student is getting a coffee. I say, "Oh, I didn't see you in class this morning." You don't want to be in that situation. So
there is a reason we make sure that we learn your names so we can use it later. So
yeah. They're engaged in your life, and it's a place that if you don't want that, don't come to USC. Chuhan asks a great question here. First of all, it gives a shout out saying really enjoyed the discussion. So he's already brown nosed and he knows how to work the faculty out. He's enjoying this. And he says he's wondering if is industrial system engineering more analytical or creative.
Yes.
Exactly.
I mentioned before that we have a lot of sub-disciplines within the degree. And so depending on your personal passion, you can direct your career towards that side of the profession. Definitely, there's a highly mathematical, highly analytical portion of the profession. People that do mathematical programming and optimization, and there's real application of this, of course, but it's very mathematical. It can be. You're doing things like trying to figure out how to allocate scarce resources like transplant organs in some instances, or how to place sensors in physical locations around an organization, around a facility, to make sure that you can keep track of the activities within the facility. Like think of a warehouse and you're trying to know, where are all the products and where are the automated equipment movers that are going and getting products off the shelves and bringing them back down to the people who are working in the packaging and labeling areas to send those out to customers. So there's that side of the profession, but there's also, we've been talking about human factors and project management and the interaction between people and technology. And Jim mentioned one of our faculty members who is sort of one of the leading lights in the development of additive manufacturing, which is basically rapid prototyping. How do you take a design on a computer screen and turn it into an object that you can hold in 30 minutes? But that's invention. And that one faculty member I'm thinking of is probably the most creative academic I've ever met. This is a guy who spends his life thinking outside the box and then turning it into something practical. So he's definitely using both sides of his brain mightily. And I think many of the other members of the profession who I've come across, I'm thinking now of another member of the faculty who used to work for an aerospace organization, was their chief technology officer. And his whole focus in life was getting people to work together so the company could make their products. It's a very huge profession with the opportunities to be creative and to work with people. Some people refer to ISE as not just meaning industrial and systems engineer, but also meaning I'm a social engineer, in that we engineer the social interactions within organizations.
I would
just to add to that, sorry.
Go ahead.
Jim, go ahead. Just to add to that, because you mentioned social engineering, human factors and ergonomic, when they started, it was called engineering psychology. And that is, I keep going back to human factors because that's what I know best. But having 3 different degrees in industrial systems engineering, bachelor's, master's, and PhD, in each level, you are exposed to different, numerous number of topics. So you learn a little bit from each courses that you take. You learn about financial engineering, you learn about the stochastic, you learn about probability, you learn about human factors, you learn about facility planning, you learn about the stochastic. Depending on what your focus is, you are exposed to a different topics. But towards later in like your junior and senior years, especially with the Capstone project that Professor Mo is going to talk about it a little bit more, I believe Now we give you a lot of our courses are project-based, meaning that a good portion of the class you will working with your peers on a project, usually semester long. We introduce the topic to you and we leave it up to you to use it in your project and make it into something. So you have that analytical, quantitative background, solid background at that, I can attest to that. And then you have the opportunity to make it your own. And that is where I do believe the creative part of our students is really, really shows itself on Flourish.
I want to say that in ISC education, well, first, engineering education is the deepest education I think you can get at the undergraduate level in the academy anywhere, frankly. I can't think of anything that honestly I regard as more focused on depth. And industrial engineering is a little bit shallower and a little bit broader than most other engineering disciplines, but it's still much, much deeper than anything outside engineering. And we tend to acquire a lot of undergraduates as they move through the curriculum. A lot of undergraduates switch into our program because they decide once they've acquired a lot of depth that a little bit more breadth is a good thing. So Kurt was really only teasing a little bit when he said yes. The right answer really is yes.
I agree. I think that was great. Sahana asked a question here about basically industrial systems engineering. Does it require hands-on building or is it more computer-based? I'm curious how she would distinguish hands-on versus computer-based. But she's trying to understand, will she be actually doing things in the curriculum?
Well,
I hope so.
Yeah, I mean, I think the answer is yes, but can you talk about kind of the difference of like is she actually hammer and nail building things? I think that's where the question comes from versus designing things in the computer, but I still see both of those as hands-on, but please help us.
Certainly, there's a great deal of work that we do in computing. A lot of the analysis that we do is on computer-based models using computational tools to help us crunch statistics. One of the areas that is a big practical strength of industrial and systems engineering is the use of statistical methods to analyze data. We were probably the strongest of the engineering disciplines in terms of statistical background. And that's not like it's the only thing we do. It's just, I don't know any industrial engineer who doesn't handle data in some way, shape, or form. So it's just part of our natural way of looking at the world is objectively measuring and analyzing and, drawing conclusions in the face of uncertainty, which is, part and parcel of what we do. But there's also a number of things where you're getting your hands dirty. One of our elective courses is in manufacturing processes, where you'll take a product and decompose it, look at all the different pieces that go into it, and think about, well, how were those produced? How were those made? How would you have to sequence a manufacturing plan to reproduce a product like that? How would you design a new product and come up with a manufacturing plan for that? And along the way in that course, we introduce our students to different ways of shaping materials, different ways of doing rapid prototyping. And the project in that course involves creating prototypes of products where students are either using an additive manufacturing equipment to convert a design into a physical manifestation, or they're going out and hitting up the shops, hitting up the stores around campus, grabbing materials, getting out the hammer and the scissors and whatever to put it together, so that on the project display day, they have their prototype there and they're explaining to their peers, this is what our prototype is intended to do, and you can actually look at it and touch it and see it. The human factors course that Professor Kashi is involved in teaching. Actually, she's been involved in teaching both of our human factors courses. And as far as I can recall, both of them involve laboratory-oriented kind of activities where you're actually either trying to figure out what a workstation that somebody's going to be sitting at 6 to 8 hours a day doing a particular task, how that should be laid out so they don't hurt themselves and they can be really effective doing a job. Or if you're designing a user interface, like you're a handheld personal assistant, how can that be set up so that it communicates information effectively to the user, makes it easy to search for different pieces of information or to find different applications on the device. And they usually are talking about mocking up prototypes of that interface and trying those out, testing those on the project work. So just a few examples. Certainly my colleagues can join into the conversation.
All right, well, I'll acknowledge this because it's about to change, but one of our curricular deficits, in my opinion, was opportunities for hands-on work of the sort I think the student's interested in. And that is actually changing, and rather dramatically, I think, because as the world has become more digital, we've needed less space for books. And we've had an opportunity through a donor to repurpose a large share of the former science and engineering library into what will be a very expansive, for lack of a better term, fab lab sort of facility that's going to be available to all of our undergraduates, and which will be connected, I'm sure, to many of the courses that we teach. And that construction is underway now. So that is certainly something that you would have as part of your intellectual life if you joined us.
That was fantastic. Thank you. I think that there's two more questions we can get to, and then we'll start to wrap this thing up and be mindful of everybody's time. There are a couple questions that are leaning in this direction. I'm going to paraphrase, but what makes a student successful in the industrial and system engineering program? Are there any common traits?
Tough question.
It's a tough one, yeah.
All right, burning intelligence helps everybody.
Did you say learning or burning?
Burning intelligence.
Burning.
Right. I would say discipline, really. When I was an undergraduate, my fraternity brothers said, "Jim, you get such good grades, yet you're such an idiot. How can you explain this?" I said, "Well, I rewrite my notes, right? So I take down everything that was said in class, and I worry about getting it all. I don't worry about getting it organized. And then that day, within 24 hours, I sit down and I rewrite the notes into what will become the course notebook from which I will study when I prepare for examination. And every time I rewrote those notes, I understood them differently than I understood the material when I walked out the door of the lecture hall. And that was a magic bullet for me, and I think it helped some of them. But really, underneath that is just the discipline to adopt a routine and to systematically address the material that comes before you, to not procrastinate. If you can learn to do that, you can succeed.
I think this goes without saying, and it's not just for ISC program or any other degree. I believe participation in the classroom goes a long way. In my experience, again, I'm going to play my I was a student here card again. In my experience, all our classes have this social aspects to it. Like the faculty do go beyond the call of duty to make sure that you are engaged and help you and be engaged. USC is a great research university, but at the same time, as a faculty who's mainly involved in teaching, I can tell you that we do look at how we deliver the material. We do incorporate active learning strategies. We do care about a pedagogy that we put into our classes, and we do create an atmosphere especially for our undergraduate courses, create an environment where you are not just sitting there and being lectured to, you are part of the learning experience. So if you participate in that experience by just, maybe it's the simplest form of it is when the question is asked, answer, but at the same time, participate in the discussion. I personally believe that would really go a long way, especially with the courses, with industrial systems engineering courses, many of whom have this social aspect, psychological aspect to it. And you do have a lot to offer and participate. So I think that's another factor that I would recommend highly.
I'll add on to that. And working with students over 20 years now, what I've noticed lately in kind of a recent generation is this kind of trend of students going up to faculty members saying, what do I got to do to get an A in this class? And this trend of K through 12 education of getting the best grades possible, focusing on the A, not necessarily the material. And so what I would always encourage students to think about, regardless of major, this isn't about ISE or mechanical or computer science, it's about engaging in the community, engaging in the classroom, engaging with all participants in the educational structure, faculty, students, staff. The level of engagement that a student has in the program, their presence, their participation, their enthusiasm, that typically is a one-to-one correlation to their success after undergraduate years. It has nothing to do with GPA, by the way. It has nothing, there's no correlation of GPA to success. It has to do with level of engagement. That's what I found personally. And I think it's a little bit of what we've all been talking about. And that it talks about work level, that talks about passion, but not just trying to get that grade. The last question that I have for all of you is, it's a summary of a few different questions, so I'm blending them together, but it is, and this is how we always know we're talking to prospective engineers. They're trying to figure out what the best answer is, right? What's the best degree program? How do these degree programs differ? ISC, operations, information systems, which one should I go into? Where am I gonna have the best success? I'll preface this with, for everyone that's applying, you don't have to have this figured out when you start out. The curriculum all starts the same way. Lean to one or the other. This will be an evolution that you'll kind of go through as you go through the undergraduate program. So you'll figure it out. But can we shed any more light on this, or should we just say, no, you'll figure it out, which I'm also fine with as an answer?
I think it's quite accurate to say you will figure it out. To suggest that someone just graduating high school or even not yet quite there is going to make the magic selection that's going to satisfy their career for the next 50 years without deviation is not really realistic. I mean, certainly in my own case, I've taken a number of twists and turns along the way. And I think the best advice I could give to someone is, first of all, develop interests. Figure out what it is you like by looking around and seeing, trying things out. And then, follow along with that. And one of the great things about a university like USC is there's such a broad variety of different things you can do outside the classroom, not to mention inside the classroom. But if you're interested in theater, you can do that. If you're interested in languages, you can do that. If you're interested in music, you can do that. If you're interested in architecture, you can do that. The whole world is there. I mean, the word university sort of implies it. We study everything here. And there's nothing wrong with taking courses or joining student societies just because you find it fun and interesting. And who knows, it may just be developing a hobby for the rest of your lifetime to keep you from being bored silly doing other things, or it may flower into an entire career option. Either way, it's great.
I follow that. A passion is very important. Find something that you're deeply passionate about, but don't rush into settling down what you're going to do for the rest of your life, because not only your interest is going to change. I think Dr. Palmer's career is an example of how you would change career along the way. I started somewhere else, ended up another place, but the world around you changes as well. And that is going to change you, the social issues, the technology, everything that goes on in this really fast-pacing world that we're living in. It changes, and you will find yourself more drawn towards another, for example, a social aspect at one day, and maybe a technical changes, like a new, like AI is coming out, or like this driverless car, which was not a case maybe 10 years ago. So the world changes, and with that we evolve. But find something that you are passionate about, and that would change the world for you.
I can offer a very, very brief strategy. I mean, what you should do is what you like best. But I found it necessary to divorce myself from the expectations of my parents and anyone else. The most liberating moment of my life was when I realized that the only audience for my choices was me. That I was the only person who had to live with their consequences. I was the only person I was obligated to. So I think that you should enter this understanding that you're highly likely to change your major at some point. And that's not failure. It doesn't mean that you were uninformed when you arrived on our shores. You may have picked your major when you were 15 years old, but by the time you're 18 or 19, you're going to know far more about the options before you than that motivated, well-intentioned 15-year-old. And you owe it to yourself to take advantage of your best state of information at all times. Just be ready to do that.
That is a fantastic point to end on. Dr. Palmer, Dr. Moore, Dr. Kashi, I really appreciate you taking time speaking with our prospective students that are interested in industrial and systems engineering. This was a really great conversation. We got into a lot of depth and we answered almost all the questions that came in. So I'm really thankful. We have more faculty sessions with different departments. You can go to viterbi.live/faculty to see recordings of past events. There are a few that are still remaining to come up. And then also all of our admission information sessions are going on 2 times a week for incoming first-year students, once every other week for transfer students. And we also have some Saturday sessions as well, plus student live chats every other Sunday. There's way more information for you out there if you want to get more about USC, the Viterbi School of Engineering, and the admission process. But with that, I want to be respectful of everybody's time. We've gone over a little over an hour now. So again, Dr. Palmer, Dr. Moore, Dr. Kashi, I really appreciate it. Thank you so much. And for all of you joining us, thank you so much. We will see you next time. Fight on, everybody.